Autonomous driving is actually here today in a certain sense of the word. For example, if you go to cities like San Francisco or Phoenix in Arizona in the United States, or some other areas throughout the world, you can actually download an app, call a robo-taxi, and it'll pick you up with no one in the driver's seat.
Could you tell us, Alex, about autonomous driving systems? How did that come about for you?
For me, autonomous driving is going to be the first time we see AI systems embodied in the physical world, operating in an open environment. It's going to completely change the way we move, both people and goods in cities. And if you think about the impact of the accessibility of vehicles, what transportation does to our lives in terms of allowing us to connect with family and friends, to be able to receive and move goods. The level of scale of impact, if you put it in monetary terms, it's estimated to be of the order of $6 or $7 trillion in terms of urban mobility globally as a market size. I think that level of impact for me is what drew me to that problem space.
Wow. Okay. Can you just unpack autonomous driving? What exactly do you mean by that?
Autonomous driving is, I guess, the definition I'd make towards that, and I guess it's important to draw a distinction between driver assistance technologies,
Yeah.
where you have a user in the vehicle who is legally responsible for that vehicle, but you have technology that assists them how to drive, whether it's highway assistance or automated parking or technology like this. And autonomous driving, I would define that as it's when you have vehicles that can move around without a liable operator in the vehicle itself. Now, there may be some remote monitoring or some other forms of fleet monitoring around the vehicle, but the vehicle itself is driving without any liable humans in it. I think that's the best definition. The other thing, the important thing to consider, though, is the operating domain of that vehicle. Where can it drive? How can it drive? What can it do? And so when you start to think about defining autonomous vehicle applications, it's about, is that vehicle actually fully autonomous, and where and how can it operate?
There's a bit of confusion around that, isn't there? And so just as a bolt-on question, Alex, where do we stand legally right now then? Because I understand that autonomous cars, I can't just, if I was driving an autonomous car, I can't just go and have a sleep in the back and it takes me to my destination. I have to be there by the wheel just in case type thing.
Autonomous driving is actually here today in a certain sense of the word. For example, if you go to cities like San Francisco or Phoenix in Arizona in the United States, or some other areas throughout the world, you can actually download an app, call a robo-taxi, and it'll pick you up with no one in the driver's seat. So the service is here today.
Really?
And
right now?
Yeah, you can fall asleep, Gareth, if you want. You can.
That's my dream. No, I didn't know. I didn't know it was actually that was like live and happening now. I thought we were a bit away from that, but
no, it's here in some parts of the world. I think what I would describe around those is that early trials where they're quite restricted in terms of their operational design domain, their ODD. They're, for example, predominantly at nighttime where there's less traffic, or they're in very constrained, more simplistic parts of the city. They're expanding over time, but what it's important to describe is what is the difference between these constrained deployments and what does it take to have autonomy, for everyone everywhere. I think that's the gap that we see, and that's largely a technology gap. But on the regulation side, which is the question you asked, we see regulation in place that can allow that technology to operate in places like the US. The UK has some catching up to do where we're headquartered, and we're working with government right now on putting in place the legislation to enable that. There are examples of this that is where it is here today.
If an autonomous car were to park illegally, does the autonomous car effectively have personhood, and or can it be prosecuted?
Hey, so that's one of the interesting questions that we have to work through for autonomous vehicles, and I guess for AI more generally. But legislation and then sort of commercial contracts should define how that liability works. But for the first instance, we're certainly looking to build autonomous vehicles that coexist with society today, and will match the road rules and culture that we expect today.
Yeah, that makes a lot of sense, because you've also done some incredible things with the Ocado Group. Do you want to tell us a little bit about that?
To talk about what we've done at Wayve so far is, so we've spent the last 5.5 years developing and what we think of as a next generation approach to autonomy. So it's a real AI first approach that builds one single giant end-to-end neural network that's capable of doing something similar to what I described in my PhD, understanding the world around it and making its own decisions on a vehicle and understanding the complexity of the environment it can drive in. That's really powerful because it means that you can build the onboard intelligence to operate with a leaner vehicle set of vehicle hardware. It's more accessible and integratable to different kinds of vehicles, and it can scale to environments that haven't necessarily been massaged and ensured that they're issue free. So it's much more adaptable and scalable system. If you contrast that to basically where the industry's at today, the industry's built on top of robotics technology that is, in some cases, over a decade old today. It's a very hand-coded approach where you break down to the problem into different parts like traffic light detection, lane detection, mapping, um, motion prediction, and build components for each of these. Now, each component of that stack will likely use an AI system today, but the way it's put together is all engineered and hand architected. On top of that, these vehicles are told how to drive through a high definition map, a map that describes the geometry and the layout of road scenes and essentially creates a path for that vehicle to follow and tells it how it should drive. Now, the great thing about that technology is it's proven that self-driving can work with extraordinary amounts of time and cost in the orders of billions of dollars and many years. It's been able to deploy in some of these scenarios in these domains like San Francisco and Arizona. But at an extraordinary cost. The vehicles have 30 cameras, over 5 radars, 5 lidars. They've got a lot of sensor equipment on them, as well as a ton of compute that makes them costly to run. But also operate in terms of building and maintaining that high definition map. With our approach, what we've been able to do is pull away all that infrastructure and create a system that focuses on making the vehicle more intelligent. With the onboard intelligence, it doesn't need a high definition map to tell it how to drive, but a system that can drive based on what it sees. And so in the last 5.5 years, we've been prototyping that system. To go back to the question of our trials with partners like Ocado Group and Asda, so these are two of the largest grocery businesses here in the UK. We've been able to deploy our technology in grocery pilots. For example, with our partner Asda, we are now delivering groceries in a trial in parts of London. And the beauty of this, we are. And the beauty of this is because this technology doesn't pre-map and set how the vehicle should drive, we've been able to drop it into their existing operations and drive on any route within that facility's catchment area to deliver groceries to customers, even if we haven't done that specific route before. So what that means is that our trial today accesses over 170,000 customers in northwest London.
Wow. So how is the training data working for that? Can you tell us just a little bit? I mean, I know you probably don't want to completely pop up the hood if you forgive the phrase, but tell us a little bit about how you're pulling in the different data sources and making that work.
It's very similar to how ChatGPT works today. So ChatGPT is trained with a foundation model on all kinds of internet text, and it's trained to in a self-supervised manner in text prediction. In a similar way, we train our driving AI on enormous amounts of video to do video prediction, to be able to predict the future and predict motion plans and how it should be driving throughout the world. Then there's this process of feedback and alignment that takes that foundation model. In ChatGPT's case, a AI model that is perhaps full of profanity. It's full of statements that are harmful or misaligned with society, and it's aligned to something that can be trusted. In a similar way, we take this foundation model and align it with the behaviors that our fleet partners want. So whether that's a grocery company in the UK, a ride-hailing company in the US, or a public transport fleet in Europe, we want to be able to see all of this data used to align our driving AI to be trusted in that jurisdiction, whether it's to adapt to different driving cultures, like driving on the left or the right-hand side of the road, or dealing with different behaviors like the four-way stop signs you see in the US, or the drivers that you might see down in Naples in Italy. We want to be able to align with the local driving culture and ensure that the system is trusted and safe. And so that we do that through this process we call fleet learning, which is adapting the driving AI to fleet data.
That's really interesting. That you touched on the fact that you're using supervised models. Do you mind, just for our listeners who might not be so familiar with all of this, talk a little bit about supervised and a little bit about adversarial networks, just so people understand a bit more about what that means?
Yeah, of course. So we largely train our system using self-supervision. This is a synonym of unsupervised learning. So it's actually not supervised. Supervised learning is where you specifically tell, or you give a labeled example for the AI to predict. So if you have a image of a traffic light, you might label and say it's a red light or it's a green light, and you tell the AI to predict that label. Whereas an example of unsupervised learning is when you take a video and you watch the first couple of frames of that video and you train it to predict the next couple of frames. Now there's no human labeling there. It's learning from inherent structure in the data. The advantages of that is it's much more scalable because you don't need to use expensive and onerous labeling tasks on the data. It also lets you see much more diverse data because you can look at the inherent structure in it rather than having to get clean structured data sets. And so that's largely how we train our system.
Just to get the crystal ball out for a minute, Alex, how far away are we? Okay, putting you on the spot. How far away are we from having a situation whereby autonomous driving systems, autonomous vehicles surpass human drivers?
So there's a couple of ways to look at this kind of question. The first one I'd say is that the first caveat I'd say is that the autonomous driving industry has suffered from overhype and predictions that inherently the problem continues to be harder than we thought as an industry. And so we don't put out specific dates at Wayve because we want to avoid that hype. Until we build the confidence internally around seeing this. So it's going to be here next year that you see many folks in the industry saying. I think that's misleading, because you've also got to be very careful about how you define it's here. So if you took the approaches that are on the roads today at a superhuman level of safety in some of the US cities I spoke of, if you took them and brought them to the UK, with billions of dollars in a couple of years, you could replicate them here at extraordinary cost. I think it'd be challenging to create a business case for that, but you could do it. I think where they would fall down is with some of the weather patterns, the rain, the fog, the snow that we see, as well as the complexity, for example, in London with roundabouts and merging traffic. And, you don't have grid-like streets that have wide lanes with clear markings. It's dynamic and chaotic. So I stand by that. I think a different approach is needed to bring this technology to a city like London. And we certainly think that if we can get our technology to work in London, we should be able to bring it anywhere to the world, even a place like for example, Mumbai. It's not going to be here tomorrow or next year is what I'm trying to say. Having said that, the rate of progress we're seeing in AI and the rate of development that our team has been able to push, we're seeing traction in building this technology and even starting commercial trials. That it's not something that I think you're going to have to wait 10 years to experience.